Hello! This video is about solving systems of equations by elimination. So this is another method to solve a system of linear equations, that is, to figure out at what point your two equations meet or at what point they cross. So a couple steps to solving. You might want to pause the video here. Step 1 is to write the system so that like terms are aligned. Step 2 says we need to eliminate one of the variables and solve for the other variable. Step 3 says to substitute the value of the variable into one of the original equations and solve for the other variable. Step 4 is to write the answers from steps 2 and 3 as an ordered pair and check. Seems a little bit wordy at first. The steps will make a little bit more sense once we go through an example. Alright, first example says x minus 2y is equal to negative 19 and 5x plus 2y is equal to 1. So the first step said that we need to make sure like terms are aligned. What that means is we want to make sure our x's and the y's are lined up on top of one another. So like here I have x and 5x are lined up and my 2y's are lined up. So you want them on top of one another like that. It's going to make it easier later. And then step 2 is to eliminate one of the variables and solve for the other variable. Well, in this case, I'm going to eliminate my y's because I have a negative 2y in my top equation and a positive 2y in my bottom one. So with elimination, what we do is we take our two equations and we add them together to help us eliminate one variable and solve for the other. So either your x's have to match up or your y's do. In this case, our y's do. We have a 2y and a 2y. So if I take x plus 5x, I get 6x. So I'm just adding. Negative 2y plus 2y cancels. So I'm going to scribble that out or whatever. And that is equal to negative 19 plus 1, which is negative 18. So now I have 6x equals negative 18. This is a one-step equation. I can just divide by 6. I get x is equal to negative 3. So I have one of my variables. I know x is negative 3. Now to find my y, I'm going to go back to my original equations, and I can plug that x into either one of them. So I'm going to go with the top one. So if x is negative 3, I'm going to put in that right there. So I have negative 3 minus 2y is equal to negative 19. And now I'm just solving for y. So I would add 3 to both sides like we do with any other two-step. And I have negative 2y is equal to negative 16. And I divide by negative 2. So the solving part is a review. We've been doing that for a while. So that part you should feel comfortable with. So now I know my x is negative 3, my y is 8. My last step is to write this as an ordered pair. Negative 3, 8. Because that is my actual solution. That is the point where those two lines cross. If I wanted to check it, I could plug those in and make sure it works out. Alright, so on this one I have 3x plus 4y is equal to 18 and negative 2x plus 4y is equal to 8. So I can see my y's do match up. I have a 4y and a 4y. To make things a little bit easier, I like to have one of the terms be negative. That way when you add them together, they cancel out. So what I'm going to do is I'm going to multiply this top one by negative 1. I have to multiply everything by negative 1 to keep it balanced. So that top equation becomes negative 3x minus 4y is equal to negative 18. My bottom equation did not change, so negative 2x plus 4y is equal to 8. Now I have a positive 4y and a negative 4y. That way when I add these two equations, it'll cancel. So negative 3x minus 2x, negative 5x. Negative 4y plus 4y, those cancel. Negative 18 plus 8 is negative 10. And now I can solve. I have negative 5x is equal to negative 10. Divide by negative 5. And x is equal to 2. Now at this point, we know we need y. We can't have a solution unless we have an x and a y. So it doesn't matter which equation you want to plug your 2 back into. You could plug it back into 2 of our original equations, or you could even plug it into that third equation that we had after multiplying the top one by negative 1. So it doesn't matter which one you plug it back into. So I'm just going to go with the top one. So I have 3 times 2, so I'm using this one right here, plus 4y is equal to 18. Got to multiply this out, so I have 6 plus 4y is equal to 18. From here, you guys should know what to do. If you want to pause it and do it on your own, you could. Also, I'll go through the steps. So subtract 6. 4y is equal to 12, and I divide out my 4. So y is equal to 3. My final answer is an ordered pair, so I'm going to write it as 2, 3. Alright, so on to another example. This one we have 2x plus y is equal to 3, and negative x plus 3y is equal to negative 12. Some of you at this point are probably saying nothing matches up, and you're right. Because this is a negative 2x and an x, so they don't have the same coefficients. And our y doesn't have the same coefficients either. This one has a 1 in front, and the other y has a 3. So in this case, elimination is still a good strategy. We just have to multiply one of our equations by something so they match up. So in this case, I'm going to take this bottom equation and I'm going to multiply it by 2. So my top equation is going to stay the same, 2x plus y is equal to 3. But now that bottom equation is going to become a negative 2x, make sure to distribute all the way through, plus 6y is equal to 24. Now I have a 2x in my top equation and a negative 2x in my bottom equation. Okay, so from here, I'm going to add both equations. So 2x plus a negative 2x, that cancels. Y plus 6y is 7y. 3 plus, oops, that should be a negative 24, excuse me. So 3 plus a negative 24 is negative 21, divided by 7. Y is equal to negative 3. So some of you guys are maybe like, wait, we solve for x first in the other equations. It doesn't matter which variable you solve for first. So looking back up at this top two original equations, if I had wanted to multiply this top equation by a negative 3, I could have. That way this would have become a negative 3y, and I would have had a negative 3y and a positive 3y, and those also would have matched up, and I could have solved from there. So now that I have y, I need to plug it back in and figure out what my x is. So I have 2x plus negative 3 is equal to 3. Well, this is really like saying 2x minus 3 is equal to 3. So I'm going to add 3 to both sides, get 2x is equal to 6, and divide by 2. So x is equal to 3. I'm going to write mine as an ordered pair. X comes first, so 3, negative 3. Okay, here's another example of where we have to multiply either the top or bottom equation by something so it matches up. I do have a 2x and a 2x, but remember I like one to be negative. That way they cancel out nicer. So I have 2x plus y is equal to 5. This is my, or negative 5 for my top equation. Now my bottom equation I'm going to multiply by negative 1, and I have to multiply everything inside by negative 1. So I get negative 2x plus 5y is equal to negative 13. I'm going to add them together. And now the reason I multiply by that negative 1, you guys, is because then I can just use addition. I can just add my two equations together. I don't have to worry about figuring out if I should add or subtract. I can just add every time. So 2x minus 2x, those cancel. Y plus 5y is 6y. Negative 5 plus negative 13 is negative 18, and I would divide by 6. So y is equal to negative 3. By the way, if I'm going kind of quickly through these, feel free to pause them to kind of catch up and try it on your own. Now I need to plug y back into an equation to solve for my x. So I'm going to use this top one. You could use the bottom one, you'll get the same answer. So 2 times negative 3 plus y is equal to negative 5. Negative 6 plus y is equal to negative 5. I need to add 6 to both sides. So y is equal to 1. All right, I'm going to write that as an ordered pair. So, oops. Some of you guys probably caught that. I plugged that in for the wrong thing. I was wondering why my answer didn't seem right. I plugged it in for x. I should have plugged it in for y. Sorry about that. So I should have 2x plus negative 3 equals negative 5. It's like saying 2x minus 3 is equal to negative 5. Got to add 3 to both sides. So 2x is equal to negative 2. Divide by 2. So x is equal to negative 1. That makes more sense. So negative 1, comma, negative 3. Now, if I hadn't caught that error, that's why it's good to plug your answers in and check them, because then I would have seen that my answer didn't work out. All right, this is our last kind of regular problem, and our last slide after this will be a word problem. So you'll notice here our x's don't match up and our y's don't match up. So we need to do some multiplying here to make something match up. Now, it doesn't matter if you make the x's match up or the y's match up. It's still going to work out in the end, so if you have a preference, you can do what you choose. I'm just going to go with x's here since they have an opposite sign. I have a negative 5 on the top and a 2 on the bottom. So I am going to multiply the top by 2 and the bottom by 5. So if I distribute that 2 all the way through, I get negative 10x plus 4y is equal to 64. And then I get positive 10x plus 15y is equal to 50. Now I like that I ended up with a negative 10x and a positive 10x because I can just add these together. Negative 10x plus 10x, they cancel. 4y plus 15y is 19y. 64 plus 50 would give me 114. And I just have to divide by 19. So y is equal to 6. Now again, now that I know y is 6, I can plug it into any of my equations that I have. I'm just going to go with the bottom one for now. So 2x, this time I got to make sure I plug it in for y, plus 3 times y is 6 is equal to 10. Got to multiply that out, so 2x plus 18 is equal to 10. Subtract 18 from both sides. 2x is equal to negative 8. And then I would divide out my 2. So x is equal to negative 4. Final answer is going to be negative 4, 6. All right, on to our last one. Now, I know you guys like shorter videos, but I wanted to make sure to include a word problem to help you with your homework. So it says, Sam spent $24.75 to buy 12 flowers for his mother. How nice. The bouquet contained roses and daisies. The roses cost $2.50 each, and the daisies cost $1.75 each. How many of each type of flower did Sam buy? So this word problem is in a section about solving systems of equations. So my first thought when I read this is I know I have to write 2 equations. The only way I can solve a system is if I have 2 equations, which give me 2 lines on a graph that cross. If I just write 1 equation, there's nothing for me to really solve there. So I need to look for some key pieces of information. I know he spent $24.75 to buy 12 flowers. The bouquet contained roses and daisies. The roses cost $2.50 each, and the daisies are $1.75. So the first thing I looked at is the fact that he bought 12 flowers. So for this example, I'm going to do x's are roses. So then y are daisies. Now, if you had flipped this, if it were a homework problem and you did x were daisies and y were roses, it would still work out. So x are roses, y are daisies. He bought 12 total. So my first equation is going to say x plus y is equal to 12. So what that says is the number of roses he bought plus the number of daisies he bought equals 12 total flowers. For my second equation, I need to use the cost. $2.50 each for the roses and $1.75 each for the daisies. So if each rose costs $2.50, that would be 2.50x plus the cost for my daisies, which is $1.75 a piece, so $1.75y, and that's equal to his total cost of $24.75. So I have my 2 equations, and now I can choose how I want to make them match up. So do I want to multiply by 2.5 to make the x's match, or by 1.75 to make the y's match? Either way it'll work. I chose to multiply the top by negative 2.5. So my new equations were negative 2.50x minus 2.50y, and that was equal to negative 30. My bottom equation didn't change, so 2.50x plus 1.75y is equal to 24.75. Now I can add those together. Negative 2.50x plus 2.50x cancels. Negative 2.5y plus 1.75y is negative 0.75y. Negative 30 plus 24.75 is negative 5.25. Divide out negative 0.75 on both sides. And I get y is equal to 7. So he bought 7 daisies. Now I'm going to use my top equation right here to find my x because it's an easier equation. So I have x plus y is equal to 12, which means x plus 7 had to equal 12 because he bought 7 daisies. So subtract 7 from both sides. X has to be 5. So that means he bought 5 roses and 7 daisies. Oops, there we go. Awesome. Thanks for watching.